Hello again, class. In this video we are predicting why the fall of an impact of a small lightweight object like an ant is different from the small impact of a more massive object, and thinking of force action pairs and how do we measure and use forces. Let's go to this example of the impacts generated by these different masses impacting the ground as they accelerate. What do you notice here? The rubber, the stone, the steel, and the gold accelerating as they free fall due to the force of gravity. Alright, so now let's use a model to give the mass. The table gives the mass of each ball right here. The force due to gravity on the ball, its weight, is also given. So if a mass has if a mass is less, then the force generated by gravity is also less. So let's calculate the acceleration of each ball using the force. So the rubber, 9.31 times the mass of the rubber ball. So let's write this in. 8.8. It says use three significant figures, so we're going to say 8.84. 8.84. Let's draw on the slide with my pen here. Okay, the stone got 28.42. It looks like they fell at the same time, so times the mass of the stone, 82. Hang on, did I do this correctly? Let's see. 28.42. Force divided by mass. Sorry. 2.9. 9.8. So we were supposed to do divided by mass, my bad. So let's do this other one again, the rubber. 9.31 divided by so also 9.8. Let's correct here. Okay, so these, both the rubber and the stone, are both 9.8. The pattern continues. 55.37 divided by 5.65 for the steel, also 9.8, and the gold, 136.91 divided by its mass. So an object's force divided by its mass is 9.8 every time. So the acceleration of the ball due to gravity is 9.8 meters per second. Okay. Gravity is an example of a constant force that provides a constant acceleration on an object. Gravity is the force of attraction between two objects. Mass is a scalar value with no direction. It doesn't change when the system around a body changes. Okay, so the astronaut's mass will remain the same. However, the astronaut's weight is a measure of force. That will change when the astronaut goes to the moon, and the force that the astronaut can exert on the soil is different because of the size of the moon. It's a vector with direction. Its value will change for objects depending on their distance from Earth's surface. Since the moon is less massive and smaller than Earth, the gravitational attraction between it and objects is also smaller.